Hello and welcome to another drive-by code session. This is going to be a part 3 of a multi-part series on the async await JavaScript feature. Again, my friend Whitekit has made some code examples, and I'm going to replay them and explain what he did. Again, the code examples will be in TypeScript. However, if you're fluent in JavaScript, then you should have no problem following along. Again, in the examples, we'll be using a tool called the JSON server, which is a tool that quickly sets up a full fake REST API with zero coding in less than 30 seconds. And I can attest to that, and Whitekit can attest to that too. And this episode will be about looping. How does loops come into play in async await? So let's get right into the code. So this is actually the code that we ended up with in episode 1 of the series, and this is code that gives you a countdown liftoff sequence. So if you ran this, we have 5, 4, 3, 2, 1, liftoff. And as you can see, without the ability of async await, then we would end up with a series of nested set timeout statements that look kind of gnarly. But if you look at this code, there's a room for improvement here. In particular, there's a lot of repetition in this code. We can remove the code repetition here with a loop. So that's what we're gonna do. So we're gonna make a counter variable that starts at 5, and then we'll have a while loop that keeps looping as long as the count is greater than 0, and we're gonna decrease the count by 1 after each time of printing it out. And then importantly, we're gonna do a sleep of 1000 within the while loop. And then after the while loop is done, finally we're gonna print liftoff. So this code works just as before. And so if you are a seasoned programmer, you might be thinking, okay, this is pretty obvious. Why are we talking about this? What you might not have realized is that we have actually just stumbled into a territory where async await actually really has given us something that was never possible before. In the past, without async await, to do the same thing that we're doing here would have been kind of non-trivial. But I'm going to save that to the end of the episode. For now, let's jump to a different code example involving Ajax calls. So we're gonna fetch the list of the teams in our database being these. So this is the way that JSON server works is you just give it all of the data models in one flat file like this. So and if you make an API call sort of named by a particular top level property of this JSON object, it will simply grab that subsection of the JSON object. So this call gets all of the teams, and we'll use async await to wait for the array of teams. So now we know the teams variable has an array of teams in it. And then we're going to render the teams on the page. And to do that, we'll kind of make a HTML string and just keep incrementally adding tags, in this case li tags, to it to sort of assemble a list of teams. And then finally append that to the document body. So if we run this, now we have the teams rendered in an unordered list. Now, what if we also wanted to list the team members? So the way this is set up is each member of the team is actually encoded within the team object as an array of IDs. However, if you wanted to actually get the names of the team members, you actually have to make yet another Ajax call to get to fetch the person and then thus their name. So, and this is a mistake that I have seen a lot of people make. So I've seen a lot of people do this to try to get this to happen. They'll make an API call using jQuery or another Ajax library of choice, and they'll do a callback style API call like this, expecting this to work. However, this doesn't work, and what happens instead is this. We actually don't get to see any team members. So what gives? I'm actually gonna give that to you, my viewer, as a riddle. So can you figure out why this doesn't work? I'll give you a little bit of time to read this code and try to come up with the answer yourself. You're perfectly welcome to pause the video if you would like more time to come up with the answer. I'll give you a couple of seconds to decide if you want to do it or not. Okay, so if you got the answer, congratulations. That means you have a pretty solid grasp of how asynchronicity in JavaScript works. But however, if not, if you just want to enjoy the show, well, the problem is that this call here, oops, let me try to draw better lines. This call here is async. Oops. And unless we're using the async await feature, JavaScript is not waiting for this operation to finish before moving on to the next step. So that is going to mean that all of the stuff that happens inside this arrow function here, this aka the inner function here, of the stuff that happens here will be deferred. And in fact, if this is the timeline, and if this is the time where we call main, which is this function here, main, let's say main takes this long to execute. So maybe this is end of main. Main is gonna, for each team member on this line, main is gonna start this Ajax call. I'm actually gonna give it a different color. Main is gonna start this Ajax call once for each team member. So let's say there were a total of 5 team members. 5 times that this happened. You actually do it once. Oops. It'll actually spawn off one of these operations per team member. So this is team member 1, 2, 3, 4, 5. Assuming there are 5 team members. 1 for each member. So that while the code was here trying to, well, actually not here, but while the code is here trying to append, string to this LIHTML, it's already too late. This line and this line and this line and this line have already executed way before this line gets a chance to execute. And that's a problem. How do you solve it? Well, async await. We can tell JavaScript, we can tell JavaScript to just wait for this operation to finish before moving on to this line. Now that we have async await. So what do? Well, you get the promise back from the API call, and then you await it, and then store it into a variable, and then deal with it. And now JavaScript will actually wait on this asynchronous operation before moving on. And that is going to give us the desired result. We still have a small problem in that there's a little comma, a trailing comma in this list of names, but WhiteKit is going to fix that up really quick. It's going to use the entries API of the JavaScript array to also get us an index number in addition to the ID in the array. And then he's going to write a conditional that determines whether we're at the last index or not. If it's the last index, put a dot there, and then if it's not, then put a comma in there. So that should fix the trailing comma problem. Okay, now back to this. So earlier on, we said that the fact that async await allows us to basically await for something asynchronous within a loop. That's something that used to be non-trivial to do. So how did JavaScript developers do this before without async await? Because before having async await, we didn't have access to be able to use sleep to wait on a set timeout. So if all we had was set timeout, how did we achieve this? So I'll post that as another challenge to you, the viewer. Again, if you would like to take some time to think about that, you can always pause the video to do so. I'll give you a couple of seconds to decide whether you want to do that or not. Okay, if you figured it out, congratulations. But if not, then and all you wanted to do was enjoy the show, well, let's see. If you came up with something like this, so you do a set timeout inside of the while loop, then this will not work. JavaScript just gonna laugh you in the face. The correct solution, actually, let me show you what would happen if you did this. So this page is frozen now and completely unresponsive. And instead, in fact, I cannot even do any productive work here until I can close this tab. And I couldn't even close it the first time because this tab became completely unresponsive. I have to click the close button second time, and then Chrome will actually forcibly close it. So what was the problem here? Well, the problem is that, again, JavaScript doesn't wait. When you call this set timeout operation here, JavaScript will start this timer and defer the execution of these lines sometime in the future. But in this case, this sometime in the future will never happen, because this loop will actually keep going. So the while loop here, and let's say this is line number 2. After this set timeout line, the execution of the code will go to the end of the loop and then jump right back to the top. So the next line that gets executed is again line number 2, and then the next line is line number 3 again here, and then that would spawn another timer, which again will never have a chance to execute because this loop is going on indefinitely. This will become an infinite loop. And because this loop will never have a chance to get out, because we will never reach this statement that subtracts 1 from the count, and then this conditional is always testing, is the count less than 0 yet? It will never be less than 0 because we will never reach this statement. this tight loop will loop forever, therefore freezing up the browser. And because this JavaScript is too busy tight looping in this while loop, it will actually never have a chance to take a breather and then handle these timer handlers when the timer actually goes off. JavaScript actually doesn't have room to take a breather to actually execute these lines at all. So, okay, so that doesn't work. So what's the correct answer? The correct answer is recursion. You have to write a recursive function like so. And also you have to call the recursive function to kick off the process the first time. So this is kind of like a contrived while loop. You can think of this as the conditional of the while loop. So this is saying if the counter is still greater than 0, we're going to print out the count and decrease 1 from it. And then we're going to use set timeout to call this same function again in 1 second's time. But if the count is not greater than 0, it is 0, then we're done. We're not going to recursively call the function again. Therefore, do another countdown. We're done with countdowns if the count is already 0, and we're just gonna print liftoffs. And this code will do the same thing. I'll prove it to you by running it. Okay, so 5, 4, 3, 2, 1, liftoff. So this kind of a combination of recursion and asynchronous call, that is, I feel like that's something is kind of unique to JavaScript. Not that only JavaScript can do it, but it's something that I really haven't seen anywhere else other than JavaScript. Even though in the world of async await, we will probably never need to use this again, but I still suggest you taking some time to wrap your head around this, because this is a real cool concept. So that is the end of this drive-by code session. I hope enjoyed it. I hope you enjoyed it. And Wykit and I will probably be cooking up some more async await examples in the future. And I hope to see you then.